in Stockholm, Sweden. Just last week, as you all know, the Nobel Prizes in physics and chemistry were awarded to AI scientists. So this highlights the transformative power of artificial intelligence. And as you also know, natural disasters have increased in frequency and intensity in recent years. That calls for innovative solutions. In this session, we'll explore how open science and AI technologies can be integrated to enhance disaster risk reduction and resilience while addressing ethical and equitable concerns in the applications of AI in those vital applications. We're very fortunate to have a very amazing panel here with us. So, going back. So I will introduce the panel in a minute, but they have their unique expertise and experience. They will contribute to very insightful discussions in this session. But before we go into that, and we would like to get to know you, our audience. So first of all, scan the QR code. And how has your day been so far in one emoji? Great. Thank you. So everybody is happy. We need more emojis. Yeah, okay, nice. Great. Yeah, wow. Love it. So, perfect, wonderful. A lot of emotions, mostly very positive. So, yes, thank you very much. Whoa. What is hot dog? Great, awesome, amazing. So, I love all the emotions. So, let's go to the next. Which country do you come from? Let's see, what are the diversity of geographic locations? Okay, right now we see quite many countries, but the Philippines, definitely, you're the host, dominating. Wow. Many from the Asian Pacific countries, but also from other places, as far as Denmark, my neighbor. Let's see. Oh, wow. Amazing. So all over the world, thank you very much for being here. So let's go to the next. Which entity are you representing? So you select, we'll see which sector. Okay, predominantly government, but private sectors also a lot. Academic, okay, it's, wow, private sector competing with academia. NGOs are growing. All right, so we have really many, but we see 45% are government. I mean, a lot of the solutions definitely needs government support and collaboration with all the sectors, so that's amazing. Thank you. So now, it's my pleasure to introduce our incredible panel, and without delay, I would like to invite our first speaker, Dr. Faritai Rafayang. She's the head of unit in science policy and basic science, nature science sector at UNESCO Jakarta. So, Dr. Faritai, the floor is yours.
Thank you so much. Oh, I would take the pointer. Thank you so much for your introduction. Very happy to be here. Welcome, everyone. Thanks for taking the time to participate in our session. Today, they asked me to set the scene for the intersection of AI and open science. It's a very complicated task, and I need your help in that. So I'm starting with two more questions. The first question is, what does open science mean to you? So please use the same QR code and participate in setting the scene with me. Accessible for all and data sharing, public good, free, transparency, transparent access, public data, shared, source, open source, data for all, data availability, open data, everyone can access. Oh, wow. People-centric, accessible data, data availability. Is it my eyes capturing a lot of data or flexible? Transparent, easy access, ChatGPT. Information, data availability. This is great. Thank you so much. I will go to the next question. You can also keep answering later because your inputs are very, very useful for us to understand better what is the overall understanding of these topics. So the second question, yes, thanks. The answers are coming, so I don't read the question. Resources, credibility, data-driven, credibility, gathering data, privacy, too technical, silo, data-driven, knowledge, not open, accuracy, ICT infrastructures. This is very nice. It makes my task more difficult, but it's very nice to see accuracy, data privacy, credibility are coming big. Too technical also. Okay, here I start. As you see, we all have different understanding of these two topics, and the relevance differs for all of us. That's where international frameworks and standard setting instruments come in. UNESCO has recently, in 2021, has developed and adopted 2 recommendations. One is on ethics of AI, and this would be what I would like to talk about today. And the other one is a recommendation on open science. UNESCO recommendations are policy frameworks. They are non-binding, but they provide a set of principles, norms, and common values and set of actions for member states to adopt them as it fits in their constitution on a specific, especially emerging issues. What makes these non-binding instruments very strong is the process of developing them. UNESCO tries over a long process of usually 2 years to collect inputs from different stakeholders from all over the world, from different groups, from policymakers, from actors, professionals, scientists, different knowledge systems to develop these frameworks. I will just briefly go through the common values and principles of ethical AI that are mentioned in this UNESCO recommendation. The values are respect, protection, and promotion of human rights, also fundamental freedom, and human dignity. There is also a value of environment and ecosystem flourishing, to be careful that AI doesn't have harmful impact on the environment and the ecosystem. Ensuring diversity and inclusion in production of the whole AI cycle, from development of the algorithms to feeding data into them, and also having them accessible for all users. Living in peaceful, just, and interconnected societies, as our world is, and as we see that a lot in the field of DRR. Disaster doesn't know the borders, so to respond to disaster, we also need to act beyond the borders. And these values are based on these guiding principles, which is the proportionality and do no harm, safety and security, fairness and non-discrimination. Everyone has the right to participate. Sustainability. AI can contribute to sustainability, but also it can delay it. Right to privacy and data protection for people and communities and countries. Human oversight and determination. So at the end, it's human who decides if this is a accountable AI system, if the output and input has the quality or not. Then for this to happen, we also need to have transparency and explainability of these AI systems. And the citizens have the right to know when the decisions are made by any contribution of AI. And then for the decisions and all the actors to be able to have this oversight, they need to be literate about that, and they need to be aware. So digital literacy, information, scientific literacy comes very important here. And of course, we are working and living in a multi-stakeholder and adaptive and collaborative ecosystem. And this collaboration can kind of ensure this inclusivity by enabling collaboration between different stakeholders and different countries. So the question is now, how can we do this? As you mentioned, the 2 Nobel Prize last week was given to those scientists who enable structures to get data and analyze data and identify patterns and elements in those. And again, this is very relevant for data related to DRR because we need to find patterns. So the question is, how can we produce AI solutions that are responding to the needs and to the relevant context? Inclusivity comes very important here because we need, so the data system is like the body, and for it to act and be functional properly, we need to feed it with knowledge, information, and data. And for that to act in the right context, we need to feed it with the data from that context. This is why we need to also enable the science, technology, and innovation systems in the local contexts. This is how open science comes in. Open science was a movement starting in the scientific community, but it evolved in the last decades in different groups and different parts of the world. But the UNESCO recommendation acknowledges the diversity of practices and brings all these actions and movements under the umbrella of this recommendation. These actions are those that are aiming to increase scientific collaboration and sharing of information for the benefit of science and the society. They make multilingual scientific knowledge openly available, accessible, and reusable. And multilinguality, again, is very important for having AI in the right context. And they also open the process of scientific knowledge creation, evaluation, and communication to societal actors beyond the scientific community. And this applies to all fields of science, from natural sciences to human sciences. Then the recommendation goes beyond. You may know about open access, for example, open source, or open data. These are all about the outputs of science. But the definition of open science goes beyond the output and talks about opening the process of science from identifying the problems by contribution of the society, designing and co-designing the process of scientific research, having open educational resources, open data, open source codes. Again, it's very important for transparent AI. Then open infrastructures from physical to digital ones. For example, infrastructures or repositories for collecting data collecting data from different disciplines, data that can be interoperable between disciplines. And then, of course, open engagement of societal actors is very important. It's not a one-way path. It's for the citizens also to contribute in the process. It can be through collecting data, through citizen science, through crowdfunding for the kind of research that the community thinks this is solving our problems. And also to open a dialogue with the other knowledge systems, including traditional and indigenous knowledge systems, and recognizing the richness of these knowledge systems. So open science, as defined in this recommendation, is based also on several values and principles. Quality and integrity of science comes first. It cannot be sacrificed. And bringing more stakeholders and sources of knowledge ensures this. When the process is open, we can also evaluate it more inclusively. Collective benefit means that science is a common good. It's a human right. Everyone has the right to participate and benefit from science. Equity and fairness for those who produce knowledge and also for those who receive knowledge, independent of where they come from, their gender, their socioeconomic background. Diversity and inclusion, not just about the people, but also bringing in different languages, different methodologies, different sources of knowledge. And then these are based on the principles of transparency, equity of opportunities for everyone, responsibility. When we open information, when we open scientific information, and this recommendation is specifically about publicly funded research, we have the responsibility to be aware how it will be interpreted. And then collaboration, participation, and inclusion of different stakeholders, flexibility, reminding ourselves that there are different paths to open science based on the context, based on the discipline. but they are based on these values. And sustainability, making sure that the practices will be long-term by providing funds, infrastructures that can be maintained, and the governmental actors play a very important role here. So also it's about as open as possible, as close as necessary. When it comes to human rights, confidentiality, intellectual property, personal information, and the rest, it might need to be closed, but then again, it's the responsibility of the researchers to provide innovative methods to open as much data as possible in an appropriate way, in the right context. There are innovative methods, for example, for open licensing, Creative Commons licenses, and a lot of these principles come from the communities. They should come from the communities based on what they need. Fair principles, care principles about use of indigenous knowledge, trust about data repositories and online repositories are some of these principles. Thank you so much.
Thank you very much, Farita, for the excellent overview of open science. Just want to say, if you have questions, please write them in Slido in a bit here. Scan the QR code during the presentations. If you have a question, you might forget later, so just write it in Slido. You can write your questions. You can also vote for questions that are resonant with you, so that in the end, we will answer the questions that are top ranked. So yeah, thank you for your input. So our next speaker is Mr. Michael Simara. He's the weather specialist at the Philippine Atmospheric, Geophysical, and Astronomical Services Administration under the Department of Science and Technology. So Michael, over to you.
Hello, good afternoon, everyone. I will be presenting the AI for weather forecasting and DRR in the Philippines. First, we must establish that from 2022 to 2024, Philippines is the most riskiest country according to the World Risk Report. But how do we tackle that? There is the UN Executive Plan. This is used for the early warning for all. This is the framework, disaster risk knowledge, detection, monitoring, and forecasting, preparedness and response capabilities, and warning, dissemination, and communication. We'll go through that one by one. First, AI for disaster risk knowledge. This is GeoRisk PH, a multi-agency initiative led by the OST PHIVOX. It's a platform that has these many tools. One of it is the Hazard Hunter PH, where you can see the hazard maps, projections with return periods of different types of hazards. You can see, pointer. Let's see. Oops. Here at this side, you can see different types of hazard. Yeah. And this is, there is GeoAnalytics PH to provide the analytics of each kind of hazard. The AI part here is DOST-AST has a project that uses satellite data to map the post-disaster assessment of flood. Next. AI in detection, monitoring, analysis, and forecasting of hazards. Just 2023, there are a lot of news around AI beating the conventional weather forecasting based on numerical weather prediction. This is developed by Google, named GraphCast. You can see at the plots, the black one is the HRES from ECMWF, which is considered as the gold standard of numerical weather prediction. But GraphCast has lower errors consistently versus the numerical weather prediction. As an inspiration, other institutions also develop their own AI-based weather global weather models. ForecastNet by NVIDIA, Pango Weather by Huawei, GraphCast from Google, Fengwu from Shanghai AI Laboratory, Fuxi by Fudan University, and AIFS by ECMWF. They have different AI architectures. This one is the comparative performance of global AI weather models. And also, there are also examples from global numerical weather prediction that the weather agencies use. You can see that the ECMWF, JMA, UKMO, and NCEP have larger errors. Those four are the global numerical weather prediction models. And the Fengwu and Pangu are the AI models as consistently much lower error than the NWP. This is the recently started AI projects in the OST Pag-asa. One is AI for RP, or Artificial Intelligence-Powered Weather Forecasting for a Resilient Philippines. It aims to train Pag-asa staff on AI technologies and aims to develop a high-resolution weather model. And there is an AI-based flood forecasting in coordination with Korea, which aims to install observation systems and generate flood models from the observations that gathered from the observation system developed. There is this, for preparedness and response capabilities, Kawayan City, in partnership with Graphico, created a digital twin for fast post-disaster damage assessments. And there is made from an independent researcher in collaborations with UP and National Institute of Physics, where they estimate, they created the tool to determine the relief delivery time in times of disaster. And in terms of warning and dissemination, Manila City used generative AI technology like chatbots in handling the complaints. What if we also use that in disseminating and communicating hazards or warnings? These are some of the open data initiatives of the OST Pag-asa, clim.ph. You can access climatological data there. And this ClimGrid.ph produces 1 kilometer resolution climate data. Yeah. That's all. Thank you.
Thank you very much, Michael, for the in-depth examples of how the Philippines are using AI to support a variety applications in disaster management. So our next speaker is Dr. Lauriane Shadow. She's Assistant Director in Community Engagement at Earth Observatory of Singapore. So Lauriane, take it away.
Thanks, Ifan. Nice to see you all. Thanks for coming. So this is going to be a very different presentation, a very different format, and I would like you to really reflect on AI for DRR as well. So basically, I have 3 main points. So just to give you a little bit of background, I really work at the intersection between science and community. I'm very fortunate to be in that space where we can really make a direct impact from research on the ground. So my perspective today, I know, is being shared by a lot of scientists that work with me at the Observatory of Singapore, but yeah, I'm phrasing it and framing it from my own personal experience throughout these years. So basically, I have 3 main points that I want to tell you, and at the same time, I want you to experience AI for DRR as well. So it's a session about AI, so I thought I would leverage AI as a tool for my presentation. So for each point that I'm going to make, I generated an image that, not yet, but that's okay. I generated an image that I wanted, to represent basically what I'm going to say, okay? So I really spent so many hours really trying to make this image as reflecting as possible. I totally failed. There were a lot of biases, misrepresentations, not at all what I wanted to say. But basically, I took this opportunity, instead of saying, okay, I failed, let's bring this opportunity to you and basically show you what I got. And you can actually experience by yourself when you see that image compared to what I'm saying, is that actually a true representation? Okay, so the experience is that. I'm gonna be telling my 3 points, and each time there will be an image representing what I mean. So look at the image, listen to my voice, and see whether you can spot things that perhaps are biased, misrepresented. I spotted a few, I named a few on the slide, but yeah, basically experience it by yourself, okay? So here comes my first point. So there won't be much words. These are basically pretty much I have 3 slides with words, the other ones will be images. So I guess the first point, AI in open science present an unprecedented opportunity for better hazard assessments, but we need more local data, and research needs to be conducted in collaboration with and as much as possible led by local scientists. So you can see here the need for local context. Okay, so here comes, and please look at that while I'm gonna be reading what I mean, okay? So I guess the first point that I want to make, again, we all know live in a multiple hazard world. Some of the impacts being exacerbated by climate change. So AI in that sense, and we just heard that through Michael, right, presents huge opportunity for forecasting, identifying patterns, such things that are really right now, we need a lot of data, we need a lot of resources, we need a lot of scientists actually doing that. So AI gives us this opportunity of really being able to do that in a much more efficient way, okay? So the first point was really about we need more local data. We need those local data, and I think Ferry mentioned that, to really train the models, because otherwise, really, the outputs will be totally biased towards countries or places where we have more data, such as maybe the US or Europe. So in the context of Southeast Asia, already we're struggling on the science when we do the research, like we always want more data, right? But for AI, I think it's going to be very critical if we don't want the results to be totally biased. Together with the data, we also need to involve the local scientists. So this has been done as much as possible, but there are still many gaps. If we don't do it with AI, the chasm is going to be even greater. Like research can be done in the States, and they can provide forecasts and things for the Philippines, but no Filipino scientists involved, right? We really don't want that. Obviously, ethically, it's not that great, but also those people in the US might not understand the local context. They might not know the uncertainties in the data. They were not on the ground to collect the data. I was a researcher myself before. These are huge experiences that you can bring when you actually interpret the data. So these are very important aspects. I think when we move towards this open science AI sphere, to not forget the actual people on the ground and not just involve them like, oh, they will provide data, that's great, they can share, but also how can we involve them in the process as well. So just to share a little bit about what we have done at the observatory, we have a large climate program at the moment running, funded by the Ministry of Education. It's got a lot of research is going to be done across climate processes, climate and health, climate and finance, many different aspects. But across that, there are actually cross-cutting themes such as AI and community engagement, which I think are quite critical. Okay, I'm going to move on to my next. Okay, so here there are two biases I had spotted on this image. Basically, I hope that you have spotted many more, because this image is totally biased and misrepresents a lot of the things I wanted to say. Okay, the second point. AI and open data present an unprecedented opportunity for better risk assessments, but we actually need disaggregated data to enable risk assessments to be targeted and account for the intersectionality of people. I've heard many talks today actually across this whole week, about disaggregated data. I think we all know we need more. For AI, I guess that's even more critical when we move from the hazard space, where we can have the best forecasts, the best predictions, but if you actually don't have any data on the ground that are not biased, again, the same thing as the first point, if we want data to not be biased, then we need the results to not be biased, we need people data. So here, my second image, I tried my best to represent as much as possible how what the points I want to make. So, for example, something that we did recently, and I think that was talked about yesterday in one of the sessions, we did a lot of research about climate cyclones that show, okay, cyclones are basically changing intensity, changing frequency, and their tracks are also changing. So this is really great, latest research, but we actually don't really have the data to how is this going to help people on the ground. So we're actually doing that. I think it's a huge opportunity for citizen science because those data, we need them at a very high pace. Hazards keep changing, AI keeps changing. We need this data very fast. So how can we incentivize people really to provide those data? I think what is key is to think about how can they benefit from providing data. Yeah, 30 seconds. So all these things I leave you think about this. How can we actually show them that they can benefit? A lot is about education, incentives, I don't know, any kind, but I'm sure all of you can think about that as well. Okay, I'm going to go very fast to the last point. AI and open data present an unprecedented opportunity for preparedness, but we need to create solutions with the local communities as well, and using AI as a tool. This one is going to be very fast. So this is really based on my experience. I find this image very lovely. You can see the Singapore flag. So a bit biased also here, but basically the reason is that because Singapore is pushing quite strongly on AI. So we have a new college of data science at NTU, many things happening in Singapore about AI. In my current role, I get to work a lot with curriculum planners, so I guess my point here is going to be about education. For many years, I've been working on helping them with curriculum development. This is a huge task. I constantly need to update them with new case studies from the region, so we don't talk about the San Andreas Fault, but we talk about faults in the region, these kind of initiatives. This is a huge task. I think AI is a great opportunity to help us in that sphere, and we're actually already discussing how basically they will use the research that we produce or curated research to really tailor, to derive curricula for different students. So at the same time, they want us to basically give them the relevant science. They perhaps don't want the whole science. They would use AI to then extract what they need and really target each age group using AI. So I think it's a very nice, we're already discussing that. They're really trying to be at the forefront. Okay, so here are the two biases, and I'm sorry I'm running a bit late. So just to leave you here, thank you very much. These were my 3 main points. I hope you took some time to really reflect on the image, and when you use AI, maybe in the future, to really think about all this. Thank you.
Thank you very much, Lorraine, for the very interesting AI-generated images. Brought it to the discussion. I think that's excellent. So our next speaker is Mr. Satoshi Nagoro. He's the COO and head of Global Business Group, SPECT Inc. in Japan. So Satoshi, please, the floor is yours.
Yeah, thank you. Hello, my name is Satoshi Negoro from SPECT. This is an AI startup company in Japan. So I'd like to introduce the AI solution for disaster and crisis management. So can I switch to my PC? Yeah, this is SPECT Pro. Then we are providing this service in Japan, and we have so many customers. But on top of that, we launched the service in the Philippines from this month. So I'd like to show you the actual product. So this is the screen of the SPECT Pro. And this side. Then everything is in Japanese, so I translate to English so you can understand the meaning. Right? Okay. So we are using the social media as an information source. Then everybody has a smartphone now, and most of them using social media. So if something special happened in front, somebody must take a picture in the movie and post to social media. And we're using AI technology to collect such kind of information. For example, this one is a car bomb explodes in Pakistan. This is the very latest information, 1 minute ago. And this is 6 minutes ago, and the part of the road collapsed in India. And the Shizuoka Prefecture, there's a fire, traffic accident, airline delay. so many information regarding the crisis is coming up to this. And for example, in Hokkaido, there's a car rollover accident. Then, regarding this accident, it seems like two persons shot a picture and posted it. And we analyze the sentences, and we analyze the images, and we analyze the letters of the symbols, and we specify the very exact location. So you can, on the Google map, you can see the situation around the car accident. And on top of that, we can sort out based on your interests. For example, you are interested in only flood. And for example, in Saitama Prefecture in Japan. So everything is regarding the information about the flood in Saitama Prefecture. And not only the information itself, but you can plot such information on the map. Like this. So one of our customers is the local governments in Japan, so they are using Spective Pro to make a critical decision during the disaster time. Then on top of the information on social media, so internet is not so fast now, but you can overlap the other information like rainfall information, and you can overlap the traffic information. So let's wait. I renew. So during I'm waiting, and we are overlapping the camera information. These cameras are installed by the Japanese government. We are connecting the over 15,000 cameras. So, unfortunately, the internet speed is not so fast. So you cannot see. But you can see the current situation of the river, and you can see the normal situation of the river. So you can compare the current and the normal time. Then, as I said, so we already launched the service in the Philippines. So it seems like a heavy rain in the Mindanao Island. So there's so many flood information like this. You can see. Yeah, so I don't have so much time today, so I go back to the slides. Yeah, so how it works is that there are so many posts on social media. So we are using AI to collect what is happening at where. And after that, this is very important, but the human verification teams working for 24 hours verify all the information before we deliver the information to customers. So the important point is the artificial intelligence and human intelligence. AI is very great and powerful technology, but it's not perfect. But the human intelligence is very flexible and great. So we need to multiply those two, and we give the only credible information. Regarding the question about the challenges, so many people raise the point of the credibility and the accuracy. So this is very important because during the disaster time, so they don't have any resource to check whether it is true or false. So we only deliver only credible information. This is very important. Then why we are relying on social media? So left side is the advantage. It's very speedy, and so many people are using it. So coverage is vast, and the visibility. So if we got the information for phone call, it's very difficult to know exactly what is happening. But you can get the photo and images, so it's very easy to see. And we can write on the people's smartphone. You don't need to install the camera everywhere. So no hardware investment is needed. But on the other hand, there are two big disadvantages. One is that the data is too huge, so it's very difficult to find only variable information. It's like find a pin in the haystack. And another one is, you know well, the fake news. So we are using technology to overcome those disadvantages. So one is the natural language analysis. So we analyze the sentences on the post and check the words, what kind of the words inside. And another one is the image analysis. This movie was posted on Twitter in Japan before, and machine learning AI is now detecting what kind of object inside the movie. So fire engine and smoke, 1.00 meaning the 100% matching with smoke, and fire. So our AI can understand that this is related to fire. So there are so many machine learning AIs now, but our Spective AI is focusing on the disasters and crisis. So in this field, our AI is most the strongest in the world, I believe. Then last slide is how to remove fake news. So I don't have a long time to explain that about the details, but we are doing so many things by AI. We analyze the sentences, and we analyze the credibility of the person who posted the information, and we analyze the images, whether it is posted before or not. So we multiply so many methods to check, and after that, as I said, so people, our verification team, check everything before delivery. So we don't deliver the fake news. We never deliver fake news to the customers. So this is the Specti Pro. Yeah, thank you very much.
Thank you very much, Satoshi, for the excellent example and how AI can be used for all kinds of disaster information gatherings from social media or crowdsourced data. So if you have questions, please use Slido. So we are going forward to Q&A session. So yeah, please engage with our panelists. All right, so before we answer your questions, I have a few questions to the panelists. One question each, and 1 minute to answer the question. So to Ferry, what key actions should governments, decision makers, and stakeholders take to support production of quality open data that can also be utilized by AI? So you talk a lot about open science.
Yes. So actually, first, before I answer, I also refer to the recommendation. Most recommendations have a set of actions for specifically the governments and decision makers in the area of science and AI. I myself, I think it's a very multilateral, multi-layered action environment. We need policies, we need incentives, we need building the culture. Incentives are very important, especially here. We need investment in infrastructures. We cannot deal with AI and open science when we don't have internet connectivity everywhere. We need also investment in educating the human resource from scientists, innovators, but also those who provide services for them, also for policymakers to have a good understanding of these areas. And I think being very open for international collaboration, which is reciprocal from the government side, is very important.
Thank you very much. So I have a question for Michael. In your presentation, you mentioned that generative AI has the potential improving the warning, dissemination, communication. Can you please tell us how you think the generative AI can help with that? And what are the risks using generative AI? Are there some fake information in there?
Thank you for the question. One of the benefits in using generative AI is, for example, in the Philippines, we have over 100 local languages. Generative AI technologies also cover the translation of languages. So instead of we manually put put the warnings in different languages, we can use AI to speed up the process. Yes. And the dangers, we've seen ChatGPT, and people see that ChatGPT is prone to hallucination. Yeah, well, it makes up data. There is an initiative by the previous workers from OpenAI. They tried to manipulate they tried to inspect and manipulate AI models, just like what people from the neuroscience study the brain. They put an stimulus and they see how the model responds. Then they manipulate the nodes that are active in that kind of stimulus, so we can get the response that we intended.
Okay, thank you, Michael. So for Lorianne, my question is, for better preparedness, you mentioned that we need solutions that are co-created between scientists and local communities. I think that's very important. How can open science and AI help to make it happen?
So I guess during my presentation, I mentioned an example about the intersections of like scientists with curriculum planners and AI and open science. So I guess I gave this example to continue perhaps on the school aspect. Something that I think quite unique, I guess we're quite excited about it in the science area, is we never have enough resources to really collect or to really analyze all the data we have, even we always want more data. So the thing is really with AI, we can have this sense of scale, like there is so much we can do. And the idea of like localizing really or tailoring the output to the local context, I think very good. Like I mentioned in my talk about the curricula for different age groups that would take us years to basically do ourselves. So I guess another project that actually would be very good, and I'm actually exploring that, is another idea for co-creation is, for example, we always try to engage students in school about learning about their own hazards, really being engaged, not being like on the passive side. So where we could actually have students identify their hazards, they could feed that into a platform, AI, obviously, okay, here, please assume that all the biases, all the things that I've been mentioning during my talks have been addressed, then we can do that. Basically, this platform could then perhaps, if we give input to these AI algorithms to really help them move towards the next level, like once you know your hazards, you give us your local context, and then we can actually learn what the next step, what's the next level of preparedness. So that's one example. Can I just give another one, perhaps? Yeah, so the next one is actually something that some of my colleagues at the Earth Observatory have been really focusing on quite a lot, really about successes in disaster risk management. To the extent of having all sorts of awards, right? We always want to highlight also those success stories. Right now, as far as I know, it relies a lot on nominations of people actually knowing other people who are doing great stuff and sharing here. Actually, I heard so many great stories during this conference. But I'm sure there are so many more that we could actually, input and give to some sort of sharing through open science, and really have to provide, people would provide those solutions, could provide the local context they were in, provide the performance of those solutions, and really AI perhaps trying, to, when you ask for something to AI, perhaps it could give you some tailored, proposed solutions that obviously you need to vet and so on, but perhaps could generate ideas this way. So I guess perhaps two other examples.
Yes, thank you very much. I think that's a good discussion to have. Satoshi, I have a very quick question for you. I mean, you in SpecT, you use different ways to reduce fake news. And you mentioned like human intelligence, image processing. How can you scale this up? Because this is labor intensive.
We can scale up it because of we don't need so much human labor. So we have, to check the information in Japan, so we have 3 or 4 persons in one time. And they are working in shift for 24 hours. So big part of the check is done by AI. And after that, human will do the final check. So we can scale it up.
Okay, thank you. Good to know. Now we have a lot of questions coming from the audience. If you still have questions, scan the QR code. But first, we will go to the question that got voted by 11 people. How would AI work in areas with countries with low access to technology? What are the strategies to help communities maximize their efforts on AI? So, Farif, maybe first you want to give your thoughts, then Lauriane, very brief, 1 minute.
I think that's the very right time to ask this question and for everyone to answer it. We need infrastructures, we need knowledge, and it's not just about AI as a technology to be imported to the countries. We need the students, we need the young generation to have the knowledge to develop and to validate the products of AI. So we really need collaboration. We are at the point that science and technology and a lot of other factors have created a lot of divides. There is a risk that divides are not bridged, but also they are widening. So it's a very valid question. We just need to act on it. We need to do collaboration.
Thank you, Perry. Lorian, quick answer.
Yeah. I mean, she said a lot already. Spending so much time actually, so helping communities actually means understanding actually what they actually need, right? Like, it's not just like coming from our lane of this is what you actually should do. So I think a lot of to help them first, we should perhaps focus on what their priorities are. I heard that actually a lot also during that conference. We have many needs, perhaps, but what are the priorities, and really help them going towards that space, I would say. So technologies is, yeah, bring them the technology, but like, then what? What do they need? Do they actually need to understand more about the process? Do they need to learn more about the data? Whatever, but what are the priorities, yeah.
Yes, thank you both for the excellent points. Maybe okay, now we have one more. Do we know the impact of hardware of these servers of these IIS affecting the environment? And how would EVAS impact us in the long run? This is for both Michael and Satoshi. So maybe, do you want to go first, Satoshi?
Yes. Which question? So hardware?
The question about hardware impact, you know, AI model use big servers, a lot of computation resources. How does that impact the environment?
Yeah. I'm not the expert about that area, so but it must be impact. And maybe we need innovation in the electricity and the battery generation, I think. So, yeah.
Okay, thank you. So Michael, you have some comments?
For numerical weather prediction, AI models have lesser impacts than the numerical weather prediction models because numerical weather prediction models require very huge hardware, high performance computing systems than the AI when you use it. In AI systems, you only need big computing resources when you train it, but it is reusable. Yeah. You only need to retrain that in, when there is a case that it cannot cover. Yeah.
Okay, that's a great point. So next question is for Satoshi. For SpecT Pro, what % of work does human intervention take? Is AI used only for extracting relevant topics from social media? So please.
Difficult to say the percentage, but as I said, the job done by human is very small. So main part is done by AI, and the human is doing the final check. So maybe
10% or
5%, I think.
Okay. Is AI used only for extracting relevant topics, or it's used for everything else?
Yeah.
Okay, yeah, thank you. Then our next question is, with the increasing privatization of AI products for DRR, how could we ensure that climate risk information remains a public good and equitably accessible? So that's an excellent question. So who wants to answer? Yeah, so Michael?
The World Meteorological Organization is planning to provide a network for open access of data. So the direction of the World Meteorological Organization is towards open. So okay. it will be equitably accessible.
Yes, thanks. Any other comments and thoughts from the panel, Ferry?
Yes, I think we can also always remind ourselves that DRR is about empowering every individual to act wisely at the time of disaster. So having this climate and generally disaster risk data open and the knowledge open and understandable for the public is the first step for prevention of disasters that everyone should consider.
Yeah, okay, thank you. Oh, now we got a real question about cost. How much is subscription cost for SpecT? Is it free almost?
No. In Japan, so 1 month, so around 1,000 US dollars. But we decided the new, different price in the Philippines, so 40,000 pesos per month. But this is equivalent to the hire the person, one person in the rural area, I think. Yeah.
Okay, thank you. So now we have one more question. How do we reconcile the ethical use of AI in building resilience when some say it is resource intensive from minerals, electronic chips, energy, land use? That's again related to the impact of AI on the environment, right? So any thoughts on how do we we train bigger models, use more data? Or can we actually have an environmental mindset when we use AI? So anyone wants to answer that? So Ferry? Yeah.
I think it's a combination of all that you mentioned. Yeah. Yeah. It's not one solution. So.
Yeah, I think everyone, when we use AI, we need to be mindful about the ethical use of AI. So I think that everyone here needs to contribute in order to reduce the environmental footprint. I think this is the last question. How would you approach the current data gap on modeling vulnerability that has received less attention than versus exposure and hazard among AI researchers? So, Michael, do you want to say something?
In terms of vulnerability, it changes frequently. The development of the local communities is very fast, so vulnerability changes frequently. We need to coordinate with local government units to get the appropriate data that we can use for AI.
Okay, thank you. You want to say?
Yeah.
Okay, yeah, please.
So I guess a lot of work that we're doing is also trying to, so we move towards forecasting, right, with hazards as much as possible. How can we also forecast vulnerability in the future? So it's not just vulnerability now, right, because perhaps now it's too late actually. Perhaps we should just foresee, okay, what are some future vulnerabilities that we can already move now to address now before they actually become, a problem later. So I guess this is also looking forward, thinking about what could be future vulnerabilities, yeah.
Thank you, Ferry.
Do you hear me? Yes. So I also want to refer to the data gap from different disciplines. Areas like DRR that are very multidisciplinary, and each of us from our point of view may think that we have a solution, we have a technical solution for that, but it's very important also to have the perspective and data from different disciplines to have this holistic view on the issues.
Okay, yes, thank you all for the comments, and thanks audience for the excellent questions. So now we're moving to your engagement again. So please scan the QR code. What kind of AI solutions do we need for disaster risk reduction in Asia Pacific? Your input will help us to really take home the messages from your engagement, and also when developing solutions that we're mindful the needs from variety of participants, from government, in private sectors, academia, civil society. So there earthquake prediction. Okay, it's very big, and collaboration, forecasting, infectious disease, quality representation, transparency, understanding human risks, forecasting, early warning, a lot of forecasting, predictive model for coming disasters that's related to early warning. I can see risk and damage assessment, smart agriculture, Specti Pro, but simple, localized forecast and early warning. I think those are really, excellent takeaway for us in terms of thinking about AI solutions. Forecasting, early warning, flood warning. So yeah, many, thank you. Now we can see our next one. what are your key takeaways from this session after listening to the panelists' presentations and also all the discussions and the Q&As? So we want to see if we have an objective. Have we accomplished the objective of this session? You feel challenged, the fast growth of AI, a bunch of AI is good, but in moderation, AI for DRR, towards AI and open science in all countries, important role of AI in aiding DRR. So AI definitely plays a central role, and proper use of AI in DRR, public participation, engagement, intervention, AI versus human, importance of open data, definitely towards AI and open science in all countries, quality of data, collaboration, open science with AI. AI is the future, AI and ethical AI. So yes, so there definitely, I think we are achieving our goals for this session. And now it's time to wrap up. So we have heard about the need for open science, open data, open tools, open infrastructure, and the opportunity and challenges of AI in disaster management, the critical role of community engagement in co-creating solutions for disaster preparedness. We've also been reminded of the importance of addressing misinformation in crisis solutions and scaling AI, human intelligence collaborations. As we conclude, I encourage all of us to continue this dialogue and work together towards building solutions that are inclusive, transparent, and resilient. I would like to take the opportunity to give special thanks to Ms. Chinatsu Indo, Program Management Officer at UNDRR, Regional Office for Asia and Pacific, for putting together this insightful session. Big applause to Ms. Indo. She's up there. And also thanks to all of you for your participation. So applause for all of you. Let's give another round of applause to our panelists. Thank you for the excellent presentations and discussions. Thank you all for participating in this session. Thank you very much.